方老师，您能听见我们的声音吗？方老师，您能听见我们的声音吗？
我能听到。
好的。
您能听到？
可以测试一下您这边的摄像头。
好。现在还不行，不能开视频。
方老师，您这边可以再试一下。
好。
好的。可以了，可以，很清楚，很清楚。吴老师也上线了。吴老师能听见吗？
对。
吴老师，
我好像得换你。
吴老师能听见吗？吴老师能听见我们现场的声音吗？吴老师能听见吗？
能听见。
好嘞，好嘞，我们也能听见您的声音。吴老师，那个现场这边的话呢，是由美赞臣的徐老师这边来协助一块儿联合主持。稍等，我们2点准时开始。
好嘞。
都可以。
那好，distinguished experts, distinguished guests, good afternoon. Welcome to the breakout session of the food for special medical purposes. My name is Xu Sang. I'm the Chief Scientist and Innovation Officer of Mead Johnson Nutrition Great China area. Mr. Wu is online. That's why he asked me to moderate the session. We have invited 9 guests, speakers, to share with you their insights. So now I'd like to give the floor to Mr. Wu Yongning, the Chief Scientist of CFSA and Director of NHC Key Lab of Food Safety Risk Assessment. He has been in this industry for many years. Now, I'll hand it over to him. Good afternoon, everyone. Our breakout session is about food for special medical purposes. And there are several lines for this topic. One is the regulation. for the special medical food. That's the first part. And because of the babies with big heads and some other accidents related to melamine, so China revised the food safety law, which incorporates the regulations and supervision of baby formula. And now currently it's under the authority, the management of the central government. From 2015, there was the revision of the food safety law. It specified that the food for special medical purposes were also incorporated for management and supervision. So it covers the health food, baby formula, and special medical food, or the food for special medical purposes. In terms of design, apart from those updates of law, when it comes to the regulation, the establishment of the national monitoring, it covers the standards development for the above-mentioned categories, including baby formula and for special medical purposes. And because each category involves specific products, and the authority falls on the marketing bureau of government at each level, and the food assessment center is responsible for the food safety assessment. And there is this Chinese Nutrition Association, which has established many standards for those categories. They have established working committees for different categories. So National Health Commission and the Marketing Bureau work closely together to monitor and approve this special food. The food additives and food regulation cover the health food, the baby formula, and foods for special medical purposes. And we are seeing the establishment of more important standards for those categories. And we know that if you travel out of Shanghai, your house code will turn into different color. That's why we organized this meeting online and offline at the same time. But we have also invited many wonderful speakers who can talk about like the national standards for those categories. And the speaker will talk about the regulations, the concepts behind the monitoring and supervision. I think the speakers will be more familiar with this aspect. And for the rest of the moderation, I will hand it over to Xu Sa. She's the chief scientist of Mead Johnson Nutrition. So she will be responsible for the moderation work on site. So, okay, so over to you. Okay, thank you. Thank you, Mr. Wu. Thank you, Mr. Wu's sharing related, his sharing of the special food, special medical food, and its regulations and standards. So when it comes to this topic, we always want to be familiarized with the regulations and standards development. Now, I'd like to give the floor to Fang Haiqing. She's the China National she's the researcher in chief of the China National Center for Food Safety Risk Assessment. Thank you, everyone. Good afternoon. My name is Fang Haiqing. I'm from China National Center for Food Safety Risk Assessment. Are you able to see my screen? Yes. The topic I'm going to share with you is the current situation and development of regulations and standards of food for special medical purposes in China. So 4 parts. First of all, the background and significance. Starting from here. So Mr. Wu already gave you a brief introduction of the food for special medical purposes. So this type of food is to meet up the requirements for specific target group who has eating disorder, digestion disorder, metabolic disorder, and so on. And we can see it helps shorten the hospital stay, decrease the complications and mortality, and also decrease the hospitalization expenses. So you can see this is an important method to improve the health conditions of specific target groups and contribute to the industry development if we can establish the standards and the regulations. And the special medical food targets at patients with different types of diseases, and usually they have a long diseases course with very specific or complicated typing and staging. And you can see this group of people has a relatively high malnutrition rate, so they require the nutritious food to support them. So no matter it's the in-hospitalized patients or outpatients, we need to increase their nutrition level, at the same time decrease their medical expenses. We can find that the food for special medical users can give the nutritious support and reduce the complications, hospital stay. Second part, I want to talk about the regulations and standards of different countries. As you can see on the slide, a lot of words. This is a very important comparison among different countries. As we can see on the slide, we sort out the regulations and standards for special medical purposes in different countries and regions. And in 1991, the CAC published the standards for the labeling and the claim standards for the food of special medical purposes. And the code number is Codex Stan 180, 1991. It points out what are the types of foods for special medical purposes, and what are the roles or functions, and what are the target populations. For example, it can target at people who have digestive disorder, metabolic disorder, and other symptoms, or they cannot realize the nutritious demand if they have intaken other types of food. And as we can see on the slide, it also mentions the formula should be based on science and enough assessment. On the labels, you cannot have any advertising information on the labels. You should provide the basic specifications related to the food. So once it was published in 1991, many advanced countries like European Union, US, Australia, New Zealand came up with their own versions. I remember as early as 1996, EU came up with the assessment of these laws and regulations, and later they published the law, and after several revisions, the latest version was published in 2013 related to the baby formula for special medical purposes and the meal replacement for weight control and so on. Many of the regulations were based on the definitions provided by Codex, but European Union came up with some new definitions for the whole nutritious formula, non-whole nutritious formula, and so on. And also look at UK, they also come up with their own versions, not just for England, for Scotland, and for Wales, respectively. We also found the US hasn't published any specific product standards, but come up with the different revision regulations related to different drugs or medical food. In Australia and New Zealand, they published a new code in 2013, and so that's the course of the regulations developed in the world in different countries. Also in Japan, they published this standards for food of special medical purposes. And I will talk about China's codes later. Now let's take a look at the management method in different countries. So China is quite similar to Japan in terms of this registration and approval. So we use the formula to register. We have the clinical testing. And for the whole nutrition formula, we require the specific clinical testing. For Japan, it's quite similar as well. They have a very strict approval process. They have two types of formula. One is the standard formula, one is non-standard formula.
And for the requirement times and different aspects, so they have a different requirement. And before the dieting and application and launching into the market, they required the manufacturers to send the notification. And for the USA and Canada, they are consistent. They don't need a registration or notification. They need the monitoring or regulation after the products are launched in the market. And for Australia and New Zealand, they don't have local products. Basically, they are imported products. So after the standards and the regulations in different countries, so next I will focus on the status of the Chinese food standard. So just like Mr. Wu said, so in the first amendment in 2015, formula foods for special medical purposes were included for the first time. And it also clarified their legal status as food. So which means they are food. And for those special food, we also need to have a very strict regulation. So we need to offer some formulas and labelings and the safety guarantees and the efficacy of the food. For now, Chinese food special diet food standardized systems are set up. They are GP 25596, which was released in 2010 for babies, and we also need to meet the standards of the GP 29922. So they are namely the general rules for formula food for special medical purpose. And in this standard, we also make some reference from the international standard, and later I will give you more details. For example, definition, special requirements of the food. In addition, after we set up the standards, we also need to have the GCP 29923, which was released in 2013. And these two general rules and plus the good manufacturing practice are detailed in the special food amendment, and we are also making some amendment, and we are also modifying and working on the setting up of more stricter systems. And next, I also would like to give you the detailed introduction of 29922. Maybe you have some understanding of that. Here, I just give you an overview of that. So 29922. For now, we haven't released the whole content. And the 29922 is a leading standard. So first, the standard framework, which is very simplified. So the scope is for the population who are older than 1 year old. And next, the terminology and the definition. So we'll give a very detailed definition of special medical use formula food. And thirdly, technical requirement, which are very important content. And the technical requirement, you can see we have some basic requirement and specific requirement for materials and nutrient and safety and limits of the containment and etc. And fourthly, others, which is still very important. For example, the packaging and the instruction and etc. So next, appendix A and B. So they covered the special whole nutrition formula food, and B is for the amino acid of the special medical use formula food. So just now we spent some time to introduce you to 9922. And next, I want to give you the definition of the special diet food. So just now we said this definition is formula food for special medical use. The formula food is specially processed and prepared in order to meet the special needs of the restricted digestion and absorption disorders and or some specific disease status. And some such products must be consumed alone or in conjunction with the other foods under the guidance of doctors. And this is not a drug, and it cannot replace the medical drugs, and the product must not claim the prevention and the treatment function of the disease. And the product classification can be divided into 3 parts. The first, the whole nutrition formula food can be taken as a single nutrient source to meet the demand of the targeted population, and the specific total nutrition formula food are used for those population in specific medical conditions with specific nutrition demands. And the non-whole nutrition formula food can only meet the demand of partial nutrition demand. They cannot be taken as a single nutrition source. They are only the supplement of the nutrition for those population. And some international standards also propose that first, the popular formula need to be evidence-based. And later, I will also give you some more details about the technical requirement and the raw material requirement and the sensory requirement have to meet specific requirement. And so-called the whole nutrition formula food, they are also based on different population demand. For example, 1-year-old to 10-year-old population every day, the energy requirement is 0.5 and etc. And we also have some substantial nutrition demand. So here I will skip all the details. You can read the slides. And next, the nutrition ingredients requirement. So here we have some tables, which includes all the detailed description. For example, the energy and the protein and the fatty acid demand for different population. And for and we increased the net energy from 0.5 to 0.7, and the fatty acid was decreased. And for the mineral requirements, we classified 25 minerals contents, and for those who are older than 10-year-old, we also have a specific requirements. And next, the specific whole nutrition formula foods. Here we have 13 types in the Appendix A, and we have also some specified descriptions here. For example, for diabetes patients, so we have some requirements in terms of the carbon dioxide and etc. And in the Q&A session of the specific population, we also describe the different requirements, and we offered some different data. And we also offered the key parameters requirement and the detailed description. And for non-whole nutrition formula food, to meet the demand of the specific population in specific period, we also have some specific requirement for carbon dioxide and protein and etc. Here I will skip the details. And the next, I think the safety is very important, and the later speakers will also cover this part. I will skip this part. So I think all the parameters of the safety, the basic is the scientific evaluation, and with the precondition we have made the complete investigation. We also consider some different classifications, descriptions. And for the food additives, here I have some specific requirements. We make the reference of the GB2761 for those population between 1-year-old to 10-year-old, and for those who are above 10-year-old, we also have similar reference materials from GB2760. And after that, I believe I want to give you more details. And we are also making some drafts of more standards. And we also collect some information of the current situation of different manufacturers. And we are making amendments for different standards. And we will give you detailed modification suggestions if you need them. And this part is about the amendment of the standards to meet the demand of the nutrition health for different populations. And we also have to meet the demand of our national state council. So it means we need to change our mindset. We need to change from the disease treatment to the health of Chinese people centered. And here we also listed some example compared with various foreign food in different countries. For now, we cannot meet the demand of the specific population in China. And recently, we are also working on the standards modification. So just now, we also covered 13 specific whole nutrition, and we set up the projects, and we are making the amendments of those standards. And through the 2992 standard modification, we are making more amendments for different standards. And we know that the special diet food has different applications, and we are just starting, and we are facing a lot of challenges. So we need to improve the formulas and the registration and regulation system need to be completed. And medical institutions, patients also need to improve the awareness of the clinical nutrition. And now the charging of the special diet food also need to be improved. So that's the challenges we are facing. And to solve those problems, we also need to think from different aspects. We have so many patients, and we also need to improve our designing to meet their clinical demand. And we also need to realize the standards improvement. And for clinical doctors, we also need to think about how to offer options for them. And here, we also need to improve our standards. For example, how to get the connection with the special purpose medical food for babies and different populations. And next, the nutrition standard system under the food safety laws. So for the time's sake, I will skip the details. So I will focus on the special diet food standard system. So here, 3 aspects. First, the general standard and the special standard for different population, and the labels for different special diet food. And we also need to focus on the quality standard of food supplements. So that's a basic of our system.
And we also have the standards for the special medical foods, and also the standards for the baby formula, baby other baby foods, and special meal food, and the standards for the 45 years, and so on. And another part is other nutritious related standards. For example, the guidelines for the nutritious meals supply and the guidelines for the FSMP and so on. So you can see under the umbrella of the food safety law and the nutritious standard system, we covered almost every part of the food. So as Mr. Wu mentioned earlier, what we need to do is how can we apply them in our industry in a better way. So as you can say, some other basic standards, some are the standards for the special meal, special food, and there are other nutrition-related standards. As we continue to improve and complete the standard system, we can serve the industry better and satisfy the population's needs and contribute to the Health China development. So that's all from my part. So I welcome you if you have any questions regarding my presentation. So that's all from me. Thank you. Thank you, Ms. Fang, for your wonderful sharing. She helped us sort out the regulations and standards in China and in other countries. He also shared with us the challenges we are facing with. And as we continue to improve our technology and the science, we can continue to support populations with better nutrition. The second speaker we invited is the head of the Nutrition Health Innovation Institute of Mead Johnson, China, Brian Liu. The company has been in China for many years. They try to combine their scientific innovations with China's reality, and they have come up with many wonderful achievements. Now let's welcome Mr. Liu. Okay, thank you very much for Ms. Xu's introduction. Distinguished guests, ladies and gentlemen, good afternoon. Today I'm going to talk about the safety assessment and clinical verification for the FSMP product development, including the baby formula. So I'm going to cover three aspects. First of all, what is CMPA, cow's milk protein allergy? CMPA is an adverse health effect arising from specific immune response that occurs reproducibly following exposure to cow milk protein. The incidence globally is about 6%. On the right chart, you can see what are the symptoms as a result of the CMPA, especially when the babies are less than 2 years old, you will see many symptoms related to the digestive system and skin system. And as the baby grows older, we also experience the symptoms related to the respiratory system, nervous system. For example, we can see the eczema, the blooding stool, and many other symptoms. At around 12 months, majority babies have established the tolerance to the cow's milk protein. And very few number of kids or population will never be tolerant to the milk for the rest of their life. The European ESPGHAN has published a diagnosis workflow for the suspected CMPA symptoms. So through the medical history, the physical checks, and the lab testing, it can develop the anaphylactic shock or definitely immediate reaction. And after the activation by food, by avoiding the milk protein, we conducted the specific IgE testing, and then the result can be positive or negative. And you can see we can follow the diagnosis path based on the results we take, whether there's clinical symptoms or improvement of the symptoms, or the negative or positive of the specific IgE. And in US, American Academy of Pediatrics also come up with their criteria of hypoallergenic formulas. So they come up with this 95% of confidence interval. These tests should at a minimum ensure with 95% confidence that 90% of infants with documented cow's milk allergy will not react with defined symptoms to the formula under the specific conditions. Let's see what kind of reactions they have when they have the allergy. So there are the two types of allergy. One is innate allergy. One is the acquired. And we can see there are different Dalton DA. For example, for the B cell, when the minimum of 1500 Dalton, then it will turn into plasma cell. And so after first time exposure, the plasma cell, the body overproduce IgE antibody, and then the IgE attached to the mast cells, and then with second exposure, we're getting to the primed master cells release, and then we'll develop symptoms. The European Medical Journal published some articles related to this, and they also had a forum related to this topic. And we compare the different degrees of hydrolysis and the residue antigen, and we found the proportion of peptides larger than 1200 Daltons, ranging from 1 to 36%. So as you can see on the chart from left to right, as long as it's larger than 1200 Daltons, the polypeptide is smaller than 5. So small possibility of allergy. If it's larger, if it's between 5 to 15%, their allergies possibility is getting larger. And this is the antigen of a cow milk protein. And you can see among the cow milk protein, there are part of it whey protein, part of it casein. So I'm going to talk about the lactoglobulin and the alpha casein. You can see they have different structure features and physical chemical features. For the beta lactoglobulin, from 9 to 12 amino acids, it will lead to the allergy. And for the alpha casein, you have to have over 30 amino acids, then it will lead to the allergy. And here is the quality control of the hydrolysis baby formula. And you can see the beta lactoglobulin doesn't have a very stable stability after the hydrolysis. It requires the LQ 10 to 400 times. And you can see on the right corner, that's for the calcium. And for different batches, it has good stability with a good distribution of the molecules. So on the left chart, you can see the numbers jump up and down. But for the casein, the it has very good stability. So that's a comparison between lactoglobulin and the casein in terms of the residues. And also we can see the quality control of the casein is much more stable. And here the IgE binding capacity of beta lactoglobulin. And we can see the result here. And this is the casein. The molecular weight is from 12 to 207 amino acids. You have to go larger than that to get to the allergy. Here is the filtration, ultra filtration process of EFH. And you can see for the Mead-Johnson Nutrimingen, the casein hydrolysates 95% smaller than the 1,000 Dalton. And the complete protein, it can range from 110 Daltons to thousands of Daltons. Another thing is 50% is the free amino acids and 50% is short peptides. We had the hydrolysis based on the beta BLG, but there is a residue. If the residue is not well controlled, it will lead to antigen allergy. And we can see Nutrimingen has the smallest residue of the BLG peptides, which means it has a very low antigenicity. And you can see those are the peptides and peptide sequence for the Nutrimingen. And you can see as long as it's smaller than 30 amino acids, it doesn't have the allergenicity. And we compare the Mead-Johnson with other brands. We can see Mead-Johnson products focus on the hydrolysis, which has a very good low allergenicity. So you can see it will not induce the specific allergy or allergic reactions. And here is the antigenicity of Nutrimingen IgE binding. You can see the chart on the right. And here it demonstrates the tolerance to the cow milk protein from the age 1 to age 2, and there are no symptoms. Based on the clinical tests and the mechanism of cow's milk, we covered the proteins, features, and how can we do hydrolysis of the protein, how to avoid the small peptides generation. But we also look at the disease or allergy generation by looking at the Th1, Th2.
And how to balance the different ingredients and the Th2. The reaction is very active. And in addition, we will add more active ingredients so we can try to adjust the immunity system. And here the graph shows you Th2 is overactive and it caused the allergy. And the Th1 in the whole tolerance. This is a process to build the whole balance system. And this is the system I just demonstrated. So after it's balanced, so we also have some active peptide. And we also compared our products with pure amino acid because we can build some tolerance and shorten the tolerance building time for babies. And 10 years ago, the LGG started to be valued, and now Mead Johnson's made the most of the experiment, and we also make some research in the safety and efficacy of LGG. And through the secretion of the short chain fatty acid, we can protect the complete of the intestinal membrane. And finally, the baby can build the tolerance for babies. And LGG, which is also very familiar for you. Why we choose LGG? For example, we can try to induce the tolerance, and those are the advantages we have in the slide. And I will skip the details. And we can also observe that the symptom of the allergy are eased much better. And we also see that this is significant in the statistics. And after the tolerance is built, before the LGG added, we also compared that with the LGG added after that. We build the tolerance for babies, and we can see a very good improvements for babies and benefits for babies. So we also thought that if we don't have LGG, the tolerance acquisition will be lengthened. And if we can give the amino acid formula to babies, maybe they can acquire the tolerance when they are 2 years old. And later, we published some papers, and we also make some research in Mead Johnson's. And we also can observe that LGG can help to decrease the future allergic manifestation. And we found that we followed up with all those babies, and we found the functions of LGG in different times for babies' growth process. And 18 years ago, Mead Johnson is first manufacturer produced the anti-allergy formulas. And in the past 80 years, we continue to make the scientific research, and in this process, we achieved more than 100 clinical researches, and we continue to make efforts to solve the symptom of baby's allergy. And for the short term, mid term, and long term, the safety and efficacy clinical are approved. And we are continuing making efforts to improve the quality of life for babies. Thank you for your attention. Thank you, Dr. Liu. So because Nutrisciences product is celebrating the 80th years anniversary, and in this process, in 80 years, we finished a lot of scientific research. And next, we will invite Zhong Huaining, who is a director from a National Reference Laboratory for Food Contact Material, China. And he is a professor in this field, and he is also the expert. And we are very honored to have him here. So welcome, Mr. Zhong. Thank you for your introduction, and thank you for the invitation from the organizer and Mead Johnson's. So I have this opportunity to introduce you this topic. And today my topic is migration and risk assessment of key substances in FCM of special food. The first introduction of our lab. So we set up the clinic lab in Guangzhou, and we are organization set up by General Administrative of Customs in Guangzhou. And in the recent years, we continue to make some researches in this field. Especially this year, we published some papers, and we are also awarded and sponsored by national departments and agencies. It means national authorities continue to give attention to the research in this field, and we also make some achievements in this field recently. And first, let's start my topic today. The food and the food contact materials are everywhere, and our efforts is to improve the quality of life every day, from the packaging of food and the processing equipment. We can see and we can find the material contacted to food. The function is to prevent the pollution and contaminant, and we can also meet the demands of the long distance delivery and the long time storage. So with the chemical and physical functions, we can help those manufacturers to process the food and improve the experiences of the customers. It means that's also very important development direction, and that's also a very important part in this field. But we also use a lot of chemicals in the food contact materials, and we have many complicated applications, and we cannot neglect the migration and the risks of the materials in this process. And we also have to focus on the resources of the food contaminant. And in this field, some scientists published some papers, and they said the food contact materials may give the major risks to our consumers. So we have to give attention to the risks of the food from the food contact material. So our topic is the special food. And just like the previous speaker said, the special food are facing specific populations and specific demands, and so they can provide the nutrition support for them. So the special food packaging safety is more important, and we should make sure that safety and the function cannot be impacted. For example, for those population with allergy, the packagings are more important, and the packaging of the special food are metal cans and the complicated soft packaging and plastic packages. Then next, we may have some risks from those aspects. First, two types. First, the unintended additives. For example, the additive migration. For example, for those migration from the chemicals, we may see the contaminants to our special food. And additives, for example, some different chemicals may also cause the damages and risks to our special food, especially from the plastics with a lot of additives. And they may cause the risks to our consumers' health. And another type is non-intended additives. Here, we also listed them. For example, the materials risky factors, for example, PET bottles. The beverages use a lot of PET bottles, and they may cause some chemicals to our consumers. For example, the aldehyde. So that's a very important risk factor of PET bottles. And the PAA is another chemical which also need our attention. And thirdly, in the whole manufacturing, storaging, and delivering process, we may also get some contaminants. For example, the paper cups. So we also need to prevent the darkness or the contaminant from the environment. And sometimes the equipment or the production environment may also cause contaminants. And the insect organisms and the oil, lubrication oil from the mechanical equipments and the metal equipments may also cause contaminants. And next, I will give you some examples so to show you how we can prevent the risk factors for special food. So first, let's look at the traditional risk factors. First, the sensory risk factors. So which is also a very important part with a lot of attention. And for example, some plastics and additives can cause some odors, or it may violate the requirement of the GB 4806.1 when it's very serious. For example, the printing ink may also produce some hair odors. And the paper products may also produce some cheese and the acid and the bad odors. So, and the paper packagings may also cause some special odors. And another aspect in the traditional risk factors is the PAA. So including the azo pigments and etc. In the production process, we may have some food, we may have some foreign particles, which may also cause the food safety risks. And the ozone pigments, we mentioned that many times, and they may also cause the risk of the food safety. Some PAA proved that they may cause the cancer and leukemia and etc. So here are 4 parts. Here we listed the 4 substances which are listed as a group 1 level by IARC. So they are those traditional risk factors. And in our industry, we continue to adopt many measures in this aspects. We still are facing the risks in these aspects. For example, from January 2020 to June 2021, EU released more than 107 cases of the non-qualified food contact materials with PAA migration volume. And they added the PAA. The migration volume is more than 0.01 milligram per kilometer, which is higher than the limit requirement. So that's a very big challenge in the PAA management. And another aspect is the BPA and the BADGE, so which is very commonly found in our packages and the coatings.
Many coatings use the bisphenol A or the BADGE or NOGE, this kind of chemicals or materials. So most of them are the environmental hormones they can act as the estrogen, which will bring many side effects to populations. So in China, we have relevant regulations. For example, according to GB 48067, it wants to decrease the limit from 0.6 to 0.05 milligrams per kilo. And also in Europe, the European Union also came up with some requirements regarding these environment hormones to manage the metal coatings inside of the metal products. So how does China react to this kind of industry? We participate in some research, and we found that we need to solve the bisphenol A and epoxy derivatives found in many canned foods in China. Also, we found the reaction products of BADGE and can react with the methionine, which are commonly detected, which means the BADGE migrated into foods, which lead to the changes of the functional food. So that's what we found with researchers. We need to pay special attention to this part, especially the food contacting materials like plastics. So just now we talked about some traditional risk factors. Now I'm going to talk about some emerging risk factors we found in our labs. First one is propanol. We studied the risks of the propanol, and especially we found the chemical in the food contacting paper, because usually they use specific materials for the paper material, which contains the epoxy chloride, and usually it can react with water and generate 2-chloro or 3-chloro, and 1,3-DCP is listed as a 2B carcinogen. So 1,3-DCP has the hepatotoxic, and 3-MCPD has the nephrotoxic. So those are the risks from the chloropropanol. So over the years, we have carried out many studies related to the food contacting paper products. The detection rate of the chloropropanol is very high, and the qualification rate is quite low. It's commonly found in the food processing paper, kitchen towel, tissue, and paper straws. And so, for example, P75 and P95 are the high exposure consumer groups. In our lab, we participate in drafting the GB 48068. We focus on 1,3-DCP and 3-MCPD, and you can see the detection level should be less than 2 micrograms. Another emerging risk factor is the mineral oil, because it's composed of the mosh and the moa. Theoretically, it contains over 1 million components. So that's a big challenge for our analysis and evaluation. According to Europe experts, they believe the mineral oil is the biggest contaminants in human body. We found MOU in most human organs. So together with some medical institutions, we are carrying out the human milk, the mineral oil distribution in human milk. We can give you a simple recap for that studies. For example, carbon 16 has the accumulative feature. So the mineral oil can accumulate in different parts of human organs, like lymph nodes, liver, and other part of human organs. So that's mosh, and more is also mutagenic if it contains 3 benzene rings. So recent years, we want to increase the assessment of the mineral oils in products. We found the mineral oils in the food contacting paper products. We also found the mineral oil in 17 baby powder formula. For example, in one of the goat milk-based baby formula, we found mosh has the highest mosh level is 3.5 milligrams, and MOA is 0.7 milligrams per kilo. So we can see there's a wide mineral oil contamination in baby formula or baby food. So for the babies aged from 0 to 36 months, we know that mineral oils exposure is worth our attention. Another emerging risk factor is microplastics, which means the size of the plastic is smaller than 5 millimeter. It widely exists in different kind of environment. It has become a sustained contaminants in the environment. So you can see the size is quite small and is quite prevalent in anywhere. So it brings a lot of hazards to humans. We had a study. We studied the migration of the PE coating in terms of the microplastics. So with a hot cup of water of 100 milliliter, we detect 13.6 more or less microplastics. We haven't had enough researches in terms of its toxicities and many other features, and like the potential risks. Now I'd like to talk about oligomer. So you can see on the slide, there can be different types of polymers. The risks are also worth our attention, especially in the food industry. Good news about it is the current statistics from the researchers. The white polymers risks can be well controlled in those studies. For example, the PADG oligomer may bring some hazards or risks to human body. It has a certain level of migration based on the in vitro studies. They didn't affect our human body, so it doesn't require our attention. But also, PET, BET, epoxy derivatives can cause relatively low levels of environment hazards. So I think the oligomers studies are not sufficient. So if the special medical food requires the use of the coatings, I will advise you to pay attention to the safety risks related to the using of the oligomers. And there are some other emerging risk factors. We haven't had enough studies related to the coatings inside of the cans. The latest research came up with that there is a great number of migrations in terms of this product. but it's still unknown to us because 53 substances are not studied carefully. We don't have enough evaluation of them. So according to the latest evaluation methods, it identified 53 genotoxic substances like alanine and p-aminophenol and so on. So if you use the coating, maybe you can pay more attention to this aspect. So after talking about the risk factors related to the food industry, now let's pay attention to the packaging issues, especially the recycled plastics. For a special group of people with specific demands, we also need to provide a sustainable concept to consumers. So that's why the recycled plastics came into our mind. So why we need to study this part? Because the linear management of plastics is not sustainable. It's quite linear. It cannot satisfy the plastic management and treatment targets and the dual carbon circulation targets. So that's why many companies establish many goals for sustainability related to plastics, environment, and so on. That's why we have seen the reuse or recycle plastics or plastic package. So when we talk about this recycled plastics, we will think about whether it's safe or not. Many people may doubt the safety because if you recycle the food package plastics, it will naturally lead to the generation of contaminants, impurities, and so on. Can be the misuse of the food grade PET, non-food grade PET, non-PET pollution, and the plastic degradation, and so on. For example, when we were kids, we remember the plastic bottles containing the pesticides were reused by our parents or grandparents many times. So those are the things that we need to pay attention to if we want to recycle the plastics. Now, the recycled plastics is a hot topic. There are many pain points we need to solve to face up with. We carry out many studies related to recycled plastics. For example, the RPT. According to our investigation, after some sort of processing, we found through the residue test or the migration test, as long as the processes are standardized and legal, the RPE in China can be used and in our food industry. So that's quite a new observation. I believe there is a bright future for the recycled PET. So RPT, recycled PET, RPE, RPP, it's a different story. So those are the foundings from our research team, covering the RPE and RPP we found in China and in Spain. We can find, no matter in China or in Spain, we can always detect some levels of contaminants. Especially, we found quite a lot of contaminants and additives with the Spanish recycled HDPE milk box. So if we use the RPE or RPP to and use them as a package materials, we need to pay attention to this kind of issues.
Which needs us to take some special measures to control the risks of that. And finally, I want to emphasize one aspect, the special food contact materials. So we need to give attention to the special food safety. That's a basic. And we also need to give attention to the quantity of the food contact materials, which may cause some impacts to our environment. So we should be focus on the environmental friendly materials. Thank you for your attention.
非常感谢钟主任给我们的演讲啊，因为他非
Thank
常
you,
希望分
Mr. Zhou. Thank you for your direction.
包括这个食品安全、食品包装材料的风险因子
And we also give attention to the
塑料
food safety materials, and we also listen to his topics with advanced technologies. And that's all for the first session in this afternoon. And thank you for all the speakers. Thank you for your presentation, and thank you for your attention. And next, we are going to have a coffee break. And please come back at 3:30, and we will have 4 additional speakers. Thank you.
好，大家好。
Okay, good afternoon.
快到3:30了。
It's almost just 3:30. Please be seated.
那我们下半场的会议
We are going to start the second session of this afternoon. Before we start, because in the first session, we also listened to the 3 presentations and with a very good feedback. After this last presentation this afternoon, we are going to have a Q&A session if you have any questions. So next, the first speaker is Professor Stephen Brown from Wisconsin University, and he has a very good experiences and the good fame in the field of the formulas and the food quality controls and etc. And we also invite him specially to share with us the quality management and the requirement for nutrition production. Let's invite Stephen Brown to share with us.
My name is Steve Brown. It's a pleasure to be presenting to you this afternoon, if even by video. I'm the former Chief Scientific Officer and Senior VP for R&D and Quality for Reckitt, and I had a similar position in Mead Johnson for more than 15 years. Today, I will be talking to you about food safety in powdered infant formula plants. In particular, we'll talk about non-allergenic formulas and how they can be handled in powdered plants. Food safety is never static. The threats are changing, the science is changing, the regulations are changing, and the analytical methods are changing. The categories of risk and concern for powdered infant formula really haven't changed. They can still all be grouped in 4 or 5 categories: microbial mitigation, foreign matter mitigation, pest and insect control, allergen management, contaminant control and monitoring, and nutritional quality and monitoring. I'll primarily focus on microbial mitigation, foreign matter mitigation, and allergen management. In powdered infant formula plants, there are several reasons for issues, but primarily the main issues are poor plant design and poor quality systems. I consider employee errors an issue under training and poor quality systems. Raw materials need to be considered. They bring the threat of microbial contamination as well as foreign matter contamination. This is particularly a concern in hydrolysates used for non-allergenic formulas. Finally, packaging is a concern. There often is poor understanding of the material components and the migration of those materials into the product. All of these create risks. The goal, of course, of quality systems and food safety systems in powdered infant formula plants, of course, is to prevent these risks and provide safe product. The approach is similar in all plants. Physical barriers and separation, passive traffic and HVAC control, zoning approaches, I'll talk more about that later, extensive raw material programs and inspections, IQ, OQ, and PQ of the plant and the equipment, corrective and preventative action reporting and review to improve extensive quality control of finished product. As I said, multiple barriers
needed and employed. No single step is sufficient. This is typical of most plants. I don't have a lot of time for this presentation, so I'm going to focus primarily on allergen management, controlling microbial contamination, and foreign matter contamination. They have similar concepts. I've said that allergy, microbial, and foreign matter management are similar, but allergen management creates some particular issues. For example, in cleaning, it's not sufficient to be microbial clean. You can't have residual protein or dust settling from protein products on equipment. So you must also test in your cleaning process for allergens. Because allergens are transmitted through air as well as by carried in, you also need to control the HVAC specifically. Dedicated plants require similar care as non-dedicated plants, but have less critical areas. It's common in the food industry to have mixed-use plants that have allergens and non-allergens. And it can be done in carefully managed infant formula plants, and there are a number around the world, including at least 2 in the US. A specific example is Nutramegen, which is made in the US and in Nijmegen, and it's been made consistently for years without issues of cross-contamination from allergens. It does, however, require considerable care and knowledge. Let's talk a bit more about cleaning processes for allergens. You need a validated cleaning process. If you're starting with a wet process, that presents not only microbial risk, but allergen risk. Sanitizers used to clean equipment prior to wet use, or to sanitize equipment prior to wet use, don't remove allergens. So you need to have a validated process that uses wipes to set a maximum level for detected intact protein. Typically, this is done by ELISA testing. And you have to have a validated cleaning process. In a powder process, typically you would flush product through the line after all your cleaning is completed and prior to your startup. You need strict hygiene control. You need change of clothing for people coming in, since they can bring powder from raw material areas that have intact proteins into these areas. You need strict control of air filtration. This includes outside air as well as internal, and typically this is H10 to H14 filters, which are true HEPA filters. Again, strict traffic control, and even such things as cleaning materials, brushes, brooms, vacuum cleaners, all need to be dedicated for that particular product. If it's a non-allergen product. Standard QC should include testing for intact common protein contaminants. It should be a standard test for that, and there should be minimum limits, maximum limits set. Allergen management starts with raw materials and prevention of cross-contamination. And it starts from when you bring in raw materials, how you transport them, how you store them. Typically, you should store them shrink wrapped so that powder and dust from the rest of the plant do not get on these materials that are non-allergenic. Then you need to have hygiene zones and transport materials through that, and bag stripping, and then finally transport to dry blending and tipping. The dry blending itself should be done in a high hygiene zone. Air control is needed on all those areas, and double gowning and limited access for people is required. Let's talk about microbial contamination. I was going to talk about several types: Salmonella, E. coli, Enterobacter, those types of things. But given that in the US we've had 2 large Conagra recalls, Conagra is in the news again. And I just want to show you some things about Conagra and comparisons to Salmonella, and to show you the risk from Conagra. Conagra is not linked to livestock or humans, and it's adapted to dry environments. So dry powder plants still present a risk. It survives in low AW, and it's omnipresent in powder factories. It's a house bug. It's difficult to get rid of. Just a note as we start, Conagra Sakazaki used to be E. Sakazaki, just so you note. Generally, there are 4 routes that are accepted as how Conagra moves into infant formula. Through ingredients, through contamination of the formula in the processing environment in the plant, through contamination of the formula after the package is opened, and through contamination during after reconstitution by the caregiver. As I mentioned, Conagra can be very heat stable. If you compare it to other pathogens, you can see that some strains of Conagra Sakazaki are very heat stable. In addition to survival at high temperatures, Conagra also survives for long periods of time in dry powder. This creates a particular problem. Even in powdered plants, the dry powdered plants with low AW, Conagra can survive, where other pathogens typically don't survive very long in these environments. The good news, though, if you use the WHO method of preparation of infant formula, which involves 70° C water, is that Conagra does not survive very long at this temperature. Let's talk a bit about raw material sources of Conagra. Low-risk ingredients in particular are vitamins, minerals, oils, and highly processed products such as sucrose and maltodextrin. High-risk products, however, tend to be the bulk products, dairy derivatives, skim milk, lactose, caseinates, the hydrolysates in allergenic, non-allergenic formulas, starch, thickeners, fibers, those types of products. But still, you should consider Conagra as ubiquitous in the environment and should be testing all materials. Let's talk a bit about risk management of raw materials. This is often made difficult because suppliers are unaware of the Conagra issue or unaware of the allergen issue faced by infant formula manufacturers. Conagra, after all, is primarily a problem of infant formula, not of other foods. So if you're a supplier of sucrose, where the majority of your supply goes into regular food industry, it's difficult to understand the requirements and meet the requirements for the infant formula. This requires training on the part of infant formula manufacturers. Heat treatment is possible, but there are limitations since many nutritional ingredients are heat label. Finally, while food ingredient suppliers are aware of allergens and the main allergens, they're unaware of the level of concern for hyperallergenic formula, where even dust, small layers of contaminants of proteins can create an issue. So all of this requires training on it and supplier development. Let's talk about where you find Conagra in plants. I've already mentioned that it's ubiquitous. But in particular, you can find it in valves, filler heads, in equipment that hasn't been properly dried out or has condensate on it, in environmental process areas, on floors and dust collecting areas, in vacuum cleaners, in drains, gaskets, dampers, mass flow meters. So there are many areas. It sounds almost overwhelming, but what can be done? Well, constant vigilance, making sure that most of the areas of the plant are dry and only wet when they need to be, and constant cleaning. In addition to cleaning, you need to have environmental sampling to tell you what the status of your plant is. And all modern infant formula plants have an environmental sampling plan. One way it's thought to control some of these issues is to have an integrated spray drying operation. You would only have wet compounding, risk reduction because of high heat treatment, and less post-contamination. You would immediately store in big bags or tote bins and then fill. This creates some issues of nutritional losses and technically is difficult. And in practice, there's no significant risk reduction from Conagra. If we look at integrated spray drying plants versus plants with a dry blending step, we don't see major differences or large differences in the amount of Conagra in finished product. Let's talk a bit about good plant design and zoning. And this applies to microbial, foreign matter contamination, and allergen control. First of all, I've never seen a perfect plant, but the perfect plant would look something like this, Raw materials would come in one side, move through a low hygiene to a medium hygiene, be processed in a high hygiene, and then move out and be shipped out on the other side of the plant. So incoming and outgoing on opposite sides of the plant. Access to low hygiene is through a single barrier, a single changing facilities, but access to high hygiene is through at least 2 barrier controls. I've seen many good plants that control the flow of people, goods, and waste, but none that are perfect. Here is just an example of controlling materials or raw materials coming into the plant. They would typically be received and then go through a transfer process into medium care and then into high care. Typically this would involve, if they're powdered ingredients, would involve bag stripping, which creates waste, and that waste needs to go out through a separate area. Zoning for people needs to be controlled as well. People need to come in their street clothes and change in the factory before proceeding and crossing a barrier into a medium care. Once in medium care, if they need to transfer it into high care, they need to change again or to double gown. So if you see the differences here between a low area and a high area, you see quite a bit of difference in the gowning. The best thing you can do, though, is to keep traffic and people to a minimum in your high care areas. All modern plants employ this approach. I'm going to talk about a couple of high-risk process areas that you need to control. One is spray drying. You need constant hygiene. Cleaning procedures that include drying out conditions after wet cleaning of the spray dryer. It's not easy to clean a spray dryer and to get it completely dry, so considerable care is needed. The design and zoning are critical. Air filtration, typically H10 or EU10 is required. You need a relative humidity less than 50%, and typical of HVAC and grading zoning is an overpressure process. Sampling, tools, staff, and ingredients all need to be controlled in these areas. Controlling the microbial and allergen contamination risk is managed by the same process in dry blending. It requires zoning, hygienic design, development of awareness of what's happening, not carrying in allergenic material, air filtration, we've already talked about, relative humidity, and again, overpressure in these high hygiene or critical zones. Powder spillages in dry powder plants is not uncommon, but it requires constant vigilance. It's part of the constant hygiene. You need to vacuum consistently and often to eliminate powder on the floors and powder on various equipment. You also need to control moisture. This prevents the proliferation of Conagra. Although Conagra is stable in a dry environment, it certainly grows faster in a wet environment. So one of our concepts for controlling not only Conagra but other bacteria is to prevent water. Bacteria can't grow without water. So nowadays, the common approach, and the best common approach, is to vacuum. This lowers the level of Conagra in the environment. There's no risk of water contamination of the lines, and the result is increased product quality and consistency. Of course, you can't always use vacuuming or dry cleaning, but it should be used in areas of low contamination with good floors and good zoning. But you should use adapted dry cleaning in areas where you still have high contamination, environment is not maintained in a dry state, floor quality may not be ideal, and there may be zoning conflicts. I've mentioned it before. Every powdered infant formula plant needs to have environmental monitoring. Else you can't tell how your cleaning is doing for microbial contamination and foreign matter and allergens, and you don't know if you have a problem. You would have a normal background level and an alert level, which would typically be 1 standard deviation above your normal level, and an action level, which is typically 2 standard deviations above. The action level probably requires immediate cleaning, intensified testing of finished material, and may even require shutting down the plant. We've already talked a little about control of allergens and control of microbial contamination. I want to talk a little bit about foreign matter and sources of foreign matter and how to control those. Foreign matter can come in from a number of areas. These include actually cleaning, so the bristles are your brushes and cleaning tools, plastic or wooden parts. They come in from the environment, glass, paint chips, plastics, threads, tapes. Pests can be considered part of the foreign matter control. They come in from personnel. You need to control jewelry, hair, wristwatches, etc., pens. And they come in from natural places, wood, and sugar, iron is common, wood splinters. And finally, from equipment, lubricants, nuts and bolts, gaskets, metals, fatigue of metals, and maintenance. So there's quite a few sources. Control of foreign matter in plants and then finally in product requires awareness and vigilance. You need to control the entry points into the plant. And you need to control entry between low, medium, and high hygiene areas. And this includes things like forklifts. You need to control the movement of raw materials. You need to control maintenance and preventative maintenance, because maintenance is taking apart and putting together things with the chance of loose bolts and gasket pieces, etc. You need to manage people and educate them about the issues of foreign management. So don't carry pens, don't have watches, etc. That's part of standard training. You need to eliminate open vats. All vats should have covers or should be tanks. You need to control air filtration and to have overpressure. And finally, every plant needs to have sieves and magnets that are in good working conditions. If you do this, you can control foreign matter. The concepts for quality and safety are not difficult, but they require constant vigilance and a 24/7 priority. Even moderately good plants can produce very, very good products, while very good plants can have quality issues if they don't have the appropriate training and appropriate approach to safety and quality. Thank you for your attention. I hope you enjoyed the presentation.
好，非常感谢斯蒂文博士的分享。
Thank you, Stephen, for your sharing. Just now he talked about he worked for Mead Johnson for 15 years. He was the chief in terms of the quality and safety. And from the presentation, you already learned that he explained the quality and safety management from the beginning to the end, from the ingredients management to the processing and the key control points from foreign matter to contamination to microbial and the allergen management. So after this part, now let's get into another topic related to the nutrition issues among the elderly. So along with the house program in China, there is an increasing attention provided to the elderly and their nutrition. Today, we are very honored to have Professor Sun Jianqing from the Nutrition Science of Fudan University's affiliated Huadong University, Huadong Hospital, and the director of Shanghai Elderly Nutrition and Health Quality Control Center. Now, over to you. Thank you, Ms. Xi, for your introduction. Dear distinguished experts, professors, and guests, good afternoon. I feel so honored to participate in today's breakout session and to share with you and also to learn from you. Today, I'm going to talk about something related to the elderly's health. And as we all know that the population aging is a global trend in the world. And in China, we quickly enter into the aging society. According to the latest studies, old people aged over 60 years old has surpassed 250 million people. In the future, there will be more people getting older, and it will be a typical trend in China. And I think that's a big challenge and opportunity for our industry. So I'm going to talk about my presentation in the following aspects. First of all, the nutritious requirements during aging. Second, what are the key nutrition-related problems in the elderly, including the malnutrition, muscle attenuation, and dysphagia. As we all know that aging doesn't happen in one day, it's a systematic process. It's a progress. It doesn't mean that you will age, but in one day or in one part of your organ, of your body, like your bone. So on the micro level, we can see the tissue cells, the organs, the system are aging altogether. Of course, the mechanism is very complicated. The intervention, there are a lot of different intervention methods, for example, nutritious food, and also stem cell technology, and many other technologies can intervene the aging process and maintain the body functions. So from health to death, we experience a long journey. You can see there's a long course of getting old. For example, we have experienced the physiological aging. So when you were young, you're like a battery full of battery, 100%. But when you age, you find your power in the battery is getting less and less. Until a point, it gives you the alert that there's not sufficient battery. So all parts of your bodies are aging. Second, there are many affecting factors, many factors. Some people aged 100 or 80 or 90, they look very healthy, but some people at the age of 50 and 60 were not doing good. There are factors like age, gender, genetics, lifestyle, disease, nutrition, and so on.
So many factors may have some impacts on the functions and the aging process. We hope that through our intervention measures, we can realize the health process in our aging period. So just now we said that many systems in our body may be impacted in that process. For example, the muscles and the joints of bones may be impacted in the aging process. We may have some intervention, for example, increase the protein, calcium, and vitamin D, and etc. And the decrease of the recognition and ignition system, and some disease in the neurology. So we may also improve the fatty acid in the daily diet, and the aging of the intestinal system is also a very severe problem. For example, the change of the intestinal system, so we can decrease the aging of those systems. With the aging and the decreasing function of different systems, we need to improve, for example, different ingredients. For example, vitamin D. Every day for young men, 40 units may be enough, and that's not enough for aging population. And that's only some examples. So for elderly people, today we talk about the quality of the food and the control of the food. So I think nutrition it should be more precise, and according to the feature and the change of the population or elderly population, we should also tailor-made the food and the nutrition intake by the elderly people. And definitely the failure of the different systems may also have impacts in the nutrition absorption. And we have some data nationally we have done in China. For example, the food intake of the elderly in China, we found that the intake of the vegetable fruit very commonly seen in China in elderly population, and the protein and the energy are taken very less in those population, and the malnutrition may also impact their health status. So there are a lot of problems in elderly people. So this is only some example. So we say that we are so healthy and wealthy, why we are still suffering from the malnutrition in elderly population. So we should also give attention to the malnutrition and the weight loss. So diabetes patients may also suffer from the malnutrition. It's not because they eat too much. Diabetes may also be caused by the malnutrition. So in that process, I think we can offer some supports to help elderly populations to improve their healthy status. And first, the malnutrition are very commonly seen in the elderly population in communities. What is malnutrition? So we have so much food to eat. How come we can have malnutrition? So you can also see is food volume intake every day is too less, is not enough, and in hospitalization rate is very high. So for those elderly population, they may suffer from the risk of the elderly population. For those who are lying in the bed every day, they may suffer from the malnutrition very commonly. And we may also see some signal. For example, the limbs are too slim, and they eat very poor, and they may also suffer from the depression and frustration and etc. So some elderly people suffered from the bone fracture and the infection. So that's some circumstances we may see. So for example, if the elderly people fell down, they may also suffer from the malnutrition because they have to lie in the bed. And for example, Yuan Longping, which is a very famous professor in agriculture in China, he fell down and hurt his legs, and finally he died because of the complicated problem and malnutrition. So the complication, the nutrition risks may increase the rate of the complications, and the breast failure, the GI inflammation and infection in skin also increased the incidence ratio. And sometimes if the protein is taken too less, it's also increased the death rate of the elderly people. So we have to screen earlier and give the elderly people more intervention measures. And the next, muscles. Everyone has muscle, and in our weight, 40 to 50%. are compounded by muscles, and that's a very important organ. And we may think that if the muscle can support our actions and movements, that's also very important life organs. And for 50% of our weight is muscle, and it can also have a very important relations with immunity and the repair ability. And Zhong Nanshan, Professor Zhong, who is also a very famous scholar in China, even he is 80 years old, he can still make a very good performance in the medical field because of the sports he is doing every day. And the muscle loss is inevitable during aging, and the muscle deterioration is common in the elderly. In this process, that's not avoidable. So every elderly may lose some muscles in the legs, and the sarcopenia is also very commonly seen. So this is a disease. That's not only a phenomenon. So that's also a silent killer for elderly. So it may cause very big impacts to elderly. For example, the function and immunity and the recovery time may also be impacted. So we have to give attention to those high risk population. Elderly is one of them. So sarcopenia is also very common in young men. If you eat very poor and you are hospitalized and you don't do the sports every day, you may also suffer from the sarcopenia. So talk about the elderly. So this is the picture in our hospital. So we have different methods to screen and diagnose and treat those people with sarcopenia. And 60% suspected sarcopenia patients account for 66% in the nursing home in Shanghai. And according to research from Singapore, suspected sarcopenia accounts for 73% of the 65-year-old population. So we also take the sarcopenia as a pillar to give more attention to the elderly people. And in the lesson, we found some papers and articles. So the sarcopenia is a very important disease which causes the loss of the longevity of population. And the muscle loss may also cause the declining in the physical functions of elderly. And the sarcopenia, in the recent 10 years, many institutions published some processes to improve the evaluation and diagnosis of sarcopenia because it's very important. For the time's sake, I want to take this opportunity to introduce you a book about sarcopenia. This is the scientific population book, which can be divided into 6 parts. I'm one of the editors of this book, which was this book was published 2 months ago. Many professors work together to write this book. We also invite different professors from different fields. And 6 chapters introduced the sarcopenia and the measures of the intervention. If you are interested, welcome to buy from Tmall or JD.com. So you can also take it as a gift for your parents. And the next, dysphagia is also a very common phenomenon for elderly. So every day we have to swallow many times every day, and it can be divided into several aspects. And the different muscles and the systems may also be covered in the swallowing process. And the left graph is normal swelling, and you can see that after the swelling, it's very easy to take the food into the epiphyse, and the right side, that's the abnormal swelling, so they can not take the food into the epiphyse esophagus very successfully. So sometimes they may also cause the pneumonia. You can see that they cannot take the food into the esophagus very successfully. And for elderly people, they have very poor teeth, and they may also lose the muscles and decrease the movement, so they cannot get the water or food directly and into the esophagus. And some elderly suffer from the Parkinson disease. They may also have the difficulties in the swallowing. And we also may see the complications, for example, the malnutrition, dehydration, and the pneumonia, and etc. They have to be hospitalized and increase the death ratio. Some elderly died may not because of the infection or disease. They may just suffer from the suffocation or the dysphagia, and they didn't realize that. It's very dangerous for elderly. And it's very important to improve the management in families. We have very few options in food, and we also don't need to improve the management of the dysphagia. So now many guidelines recommended to change the food and to improve the nutrition. Internally, we have the ADSI. The food need to be classified and into different levels. And in Guangzhou, we also organized the expert consensus. We also drafted the expert consensus in our Chinese Nutrition Society. So we divided the food into 5 levels, 6 levels, and if elderly take the very big food, so they also need to be changed in nature, and we also need to make sure the foods to be safe, good looking, tasty, and economical and nutritious. So we need to make sure the suitable kindness and the low adhesion, strong cohesion, smaller portion, and the nutrition density is very high. So we need the efforts from different organizations. And in China, in Japan, they did a good job in guarantee the reasonable diet for elderly. They offer different choices for elderly in Japan. So that's also the basis of the health of the elderly. So we don't want to lie in the bed when they are old. And we also hope that we can guarantee our quality of life when we are old. And we also need to have some strength and movement. So we also have different guidelines of nutrition.
Okay, I'm going to talk about this one. So when the old people start to get older, they start the process quickly from the age of 50. You know, from age 60 to 100, there are 40 years. So old people at different section of the old age will have different priorities. For example, for people aged 60, 70, you need to pay attention to their hypertension, high blood sugar, and so on. But if he reaches like 78, 80, 90 years old, we need to focus on the sarcopenia and other muscle attenuation problems. So there will be different focus at a different age range. And for the older people, we need to support them with good nutrition levels. So for old people, they have special needs for nutrition, which can extend their lifespan, health life, and other purposes. When we talked about special food, we also need to have special food for old people, like health nutrition fortifiers or fortified food and so on. We can support them from the edible food to the IV injection or nasal feeding and so on. So there are many choices for us. Because I'm from the Huadong Hospital Nutrition Department, we focus on the elderly nutrition for decades. And when they have like sarcopenia, dysphagia, malnutrition, and other symptoms, we have carried out many studies. We had the opportunity to give the old people more support. And we, in Shanghai, they established the first nutrition quality control center. I am the head of the center. I faced up with a lot of pressure, but I think it's a great and honored job for me. Because this institution belongs to the Shanghai Health Commission, we want to apply the innovations and scientific studies related to the elderly people. And lastly, I want to say, we hope we can provide reasonable and nutritious diet for all aged people to extend their health span. Thank you. Thank you, Ms. Shun, for your sharing. A lot of insights, case studies, researchers. So she is an expert in muscle attenuation and sarcopenia. I also read the book he just recommended. It's very helpful if you want to have more research and development, and also a good book you can give as a gift to your parents or grandparents. Next, I'm going to invite Hongxing. He's the senior engineer of Bright Dairy Research Institute. He's going to talk about the studies related to human milk lipids, which is a gold standard for the milk powder formula. So welcome. Thank you for the introduction. And also thank you all for being here and all the experts. Today, I'm going to talk about the research, simulation, and functional verification of human milk lipids. First of all, what are the nutrients inside of the human milk? It's quite complicated. Lipids are vital to humans' growth, to infants' growth and development. It's the main energy source and the source of neural development for the brain. It is also the source of the immune system's development. As you can see on the slide, the main function, here is a summary of the functions. So you can see there are several types of materials. The first one is triglyceride, which provides the main energy, about 50% of the energy, and assists in the transport and absorption of the lipophilic compounds. And another substance is sterols. And the third one is the phospholipids, which is very vital because it can promote the absorption and transport of fat digestive products in the digestive tract. And also it acts actively in the body's immune system and the nervous signal transduction. And you can see the biggest substance or the biggest part is the triglycerides in the human milk. We pay attention to the lipid acid, and we pay attention to its proportion. The fatty acid in the human milk is quite different from the other animal milk because the saturated fatty acid is quite low. Most of it is unsaturated fatty acid, including the linoleic acid and alpha-linoleic acid. So that's quite different from other types of milk. And the triglycerides structure is quite special. It contains a lot of long-chain fatty acids and exists in a form of unsaturated fatty acids. If we make a classification in terms of the triglycerides, we can find there are the distribution table here. As you can see, the C52, the OPL have the largest proportion in the triglycerides. Altogether, they occupies about 40% of the triglycerides. But of course, China is a big country. In different region, different city, the reporting results are different. For example, in Wuxi, you can see the distribution of the OPL and OPPO is high, and Beijing and moderate, and Hubei and Sichuan is quite low. So you can see there's a difference. There are differences in different cities and regions, and of course, there are different evaluation or testing methods, but we think it occupies from 30% to 50% of the triglycerides in human milk. And second, as for the phospholipids, which is another main category of in the human milk, we did a lot of literature inquiry, and we found there are 5 types of phospholipids, including the SM, PC, PI, PE, and PS. Those 5 substances the average concentration of those 5 types of phospholipids in human milk ranges stably. And for the baby formulas, the main base comes from the cow milk. Compare with the human milk. If you look at the nutrients, you can find there are many differences in, for example, the protein and the low lactose. But you can see the mass volume is quite similar, but that's why so many people are using cow milk to replace human milk. But if you compare these 2 lipids, you will find that human milk contains the lipids contained in human milk is quite different from cow milk, because in cow milk it's mostly saturated fatty acids, and in human milk, it contains a lot of palm acid, and palm acid is more widely distributed in the first position of the human milk, and about 7% of the palmitate located at the second position. So its distribution in the second position is quite beneficial for the digestive tracts among infants. I will talk about it later. And also, as you can see, the lipid groups is a key focus for us to develop the baby formula. And the human milk comes from Shanghai region, and the cow milk come from the ranch. And we can find that the research shows that the percentage of phospholates in transhuman milk is basically the same as that in other parts of the world. And the 5 types of phospholipids are quite different. However, and you can find the SM is not the highest phospholipid. Now, I'd like to briefly talk about the simulation, lipid simulation of human milk, which started by our company 5 years ago. We use the vegetable oil a lot. The typical feature of that is it doesn't contain a lot of long-chain fatty acids, and which lacks the DHA and ARA and phospholipids related to the cerebral nerve development. So first of all, we pay attention to the palm taste at the second position. And you can see this is the clinical research. It proves that if we improve the SN2 level in the formula, it can improve the whole body bone mineral content of the infants, can reach the same level of the human milk. At the same time, it decreases the proportion of saponified fatty acids. After we increase the second position palm taste, we can find the proportion of the saponified fatty acids is reduced. And also it can improve the whole body bone mineral content and improve the infant fecal properties. Another study is focused on the lipid functional properties. So first of all, we use the SM fortified milk. We use that to prove that the SM fortified milk contributes to the neural behavioral development of the low birth weight infants. So you can see after the fortification, it resembles the human milk. And we have this general adjustment of the formula. And for one part, we use the cow milk to do the fortification. On the other hand, we have the SM fortification. So it gives us a positive results. It can improve the attention among babies, which make them score similar to the babies who had human milk. After the studies of the human milk and the third inquiry of the clinical literature, we have been carrying out the baby formula simulation, the human milk lipid simulation. We had carried out the human milk lipid simulation related to the palm taste. It's not 100% resemblance, but you can see the fatty acid is quite similar to the human milk. That's what we did 10 years ago. The adjustment was did 10 years ago. And you can see the fatty acid composition is greatly improved to resemble the human milk. And after the simulation, we can see the lipid groups were greatly maintained or contained because we contain about 30% of the milk fat. With other different ingredients, we intensify the phospholipids at a high level. And at the same time, we maintain the right proportions, which resemble the human milk proportion. On the right-hand side, we got another result after different adjustments. You can see we have different lipid adjustments. And we realized the transitional milk level, and we had the simulation. And later, we had efficacy verification of this simulation. We use an animal test to verify. We hope we can learn more about the lipid adjustment and its impact on the rats' brain development, because we want to reach the same results with the human milk. So we extracted the brain tissues of the rats, and we did the analysis, and we found 100 ions. We classified them, and the cations and anions reached the levels of phospholipids. After the careful studies, we find that the rats there are no differences between the in terms of the phospholipids between the rats and the control group. We want to learn more about this simulation results. Therefore, we combine the cation and anion, and we find there are 9 classifications of phospholipids, and we find only SM has a big difference. According to the investigations and studies of the SM, we found there's only one ion existing with this difference. So we find so the single ion analysis for SM shows that only one of the 9 cations has significant differences, and the proportion of this ion is less than 5%, and the 4 anions have no significant differences. So you can see that's the only ion, and the proportion of these differences is very small. And later, we have the clinical validation of our formula. This is quite an open clinical trial because we have 3 groups. The first one is the human milk group. The second one is the open controlled group. We don't limit any brand they use as long as they don't use our brand. So they use the market formula, the market formula group. And the third one is the adjusted formula group. So what we want to check is the safety, the growth factors, and also after adjustment of the phospholipids, what are the impact on the fecal properties of babies, and also the GI tolerance and other data. So first of all, the safety studies. No matter it's a human milk or the formula adjusted group or the market standard formula, we can find these 3 groups share the same data in terms of the weight, head circumferences, chest circumferences. So there are no significant differences. So no impact on the growth and development. And at the same time, we also study the bone density. And we did the test because we want to know after the lipid adjustment, what are the improvements? With this data analysis, we found the bone density of our group is quite similar to human milk and higher than the market control group, which means the bone density is greatly improved, but you can't see any lengthened effect of their legs. So no impact on the growth, but just improved the bone density. Another thing I want to talk about is we observed the baby's fecal properties. And you can see that we analyzes the fecal frequency, defecation frequency, and the scores of the fecal properties. So starting with the intervention, and you can see in the first 2 weeks, the human milk exhibits good advantages, but from the third week, our formula starts to resemble the human milk. And the third group, the control group, with the other brands of formula, we can find the scores are lower and the defecation frequency is much lower compared with another 2 groups. In order to adjust the fatty acids, because we change the fatty acids, we want to know what are the impacts or effects on the crying, on baby crying. And we find that after 12 weeks studies, we find that in the later 4 weeks, our formula resembles quite close to the human milk group. We can see there's a great reduction of crying, so quite similar to the human milk group. And another market formula group, you can see there's no significant reduction of crying. And lastly, you can see this index here. This is an evaluation of the confidence of the product. We evaluate the incidence of the eczema. We find compared with the control group, there's a 60% reduction of the eczema with our formula, adjusted formula. And you can see the reduction is big from the severe eczema, moderate eczema to mild eczema or no eczema. So after the formula adjustment, we can find there is a great improvement in terms of the incidence of the eczema, which means our adjusted formula is quite effective. It's good or beneficial for the baby's growth and development. Lastly, I will give you an overview or outlook of our baby formula in terms of its future development. And you can see we focus more on the growth. In the past, we focus more on the growth and development of the baby formula. But in the future, as improved by the testing technologies and priorities, we will focus more on the fine components studies. That's actually a big challenge for the industry because many of the fine components can be detected with the human milk, but it's not possible to realize the industrialization of them, which means you can hardly add them to the baby formula. It requires the joint collaboration with different experts of different fields. And also, in the future, the functions of the baby formula will not just focus on the growth factors, but also the GI tracts development and the brain development. By applying the molecular technology and omics studies or technology, we can improve the baby formula's effects. Thank you. Thank you very much for your sharing. Mr. Jia shared with us what they had done over the past 10 years in terms of the baby formula and human milk simulation, including the phospholipid fortification and many studies and experiments they had done. I think the fine component studies will be a major trend in the future. Lastly, the last speaker is going to share with us the ingredient standards for baby formula and the foods for special dietary uses. Now, I'd like to invite Kenny Xie and Shunina. They are going to share with us the application of the foods for special medical purposes.
My name is Kenny Xie. I am from USP FCC. So USP is 美国药典委员会 and FCC is Food Chemicals Codex, 食品化学法典. I'm going to talk about the ingredient standards for infant formula and foods for special dietary use. So what are the differences between the infant formula, FSDU, and the regular foods? Due to the vulnerable nature of certain groups using these foods, and the fact that these foods can be the sole source of nutrition in certain cases, the composition and quality of these special foods must be rigorously controlled. So these products must be highly consistent and uniform within batch and from batch to batch, both chemically and physically. And last but not least, the impurities and contaminants must be identified and controlled and to limit it to minimum levels. So the consistency and purity depend on having precise process controls and high quality ingredients. To get high quality ingredients, we have to have a transparent supply chain. You may then ask, how can we get a transparent supply chain? So knowing that you are using high quality ingredients requires supply chain transparency. Supply chain transparency requires the accurate and clear communication. The answer here is that the standards can help this happen. So what does a food standard do? First of all, it's a common language. So it helps stakeholders speak the same language between the supplier, between the ingredient user, between the consumers, and it provides definition of quality and purity. And it also provides a source of test methods and specifications. And we'll talk about that more in later slides. And the second point is that it provides fair trade. So it helps ensure the buyers and consumers get what they think they are getting. For example, some ingredients are synthetic versus some are natural. And some are in higher purity and the others are lower. And some are from animal sources and the others are plant-based. And also that it's related to the quality and integrity. So the standards help ensure the quality and safety of the food ingredients and it can help prevent the fraudulent activities such as food fraud and other intentional adulteration. And standards are based on the ingredients as approved by the regulators. So from a different angle, how do we define an ingredient standard? According to a dictionary of food and nutrition, it is the set of criteria that an ingredient must meet if it is to be suitable for human consumption. If we take a careful look at the definition, the first point is that it needs to be suitable for human consumption. It needs to be safe and needs to be food grade. And the second point is that it is a set of criteria. So this is like speed limit. The specification and criteria basically describe what should be acceptable. And not only do we need speed limit, we also need a speedometer, which in this case is the method to measure what is the real number in the products. And if you ask all the analytical experts, they can tell you that these two, the specifications and the methods, need to be validated together. And where can we find standards with criteria and specifications and methods? So Food Chemicals Codex is one of the examples, and it's one that you can readily use. It is a compendium of internationally recognized standards for the identity and purity of food ingredients. It was created by the US FDA and the US Institute of Medicine in 1966. It is currently published by USP, a non-profit organization. There are over 1,250, and now it's close to 80 standards for ingredients and 19 appendixes. And the standards are developed by expert volunteers. And we claim ourselves a fully independent source of food ingredient standard. And FCC standards consists of the following. So it has general information that includes the description and the chemical information. And we also include the specification and method, which include the identification. It tells you it is what it is, the assay or potency or purity. So basically tell you how pure or how strong that ingredient has. And impurities such as the heavy metals, and then specific tests. Basically, we provide additional tests to ensure the quality of the products. And we also have appendixes that provide additional tests, guidances, and other information for users to use. So how can we use standards to protect your supply chain? And as a supplier or an ingredient user, or like a FSMP or infant formula producer, you need to specify a public standard when establishing the specifications for your ingredients. And then you actually need to conduct a test for compliance to that standard. So below, I have two examples of FCC standards, and I think they are relevant to the industry. And the first one is the 2-fucosylectose. It's a human milk oligosaccharide. In our standard, or we call it monographs, we have chemical names, the structure, the formula, the molecular weight, the class number, etc. And we also have description, mainly focused on the appearance of the product and the processing information. So how is it processed? What is the original materials, etc. And solubility. We also have function. So what is it used for? And the packaging and storage condition. So make sure that the users can understand where they should be stored. And for testing, we have two identification tests here. The first one is the retention of the major peak in the HPLC method. So the method is the same as in the assay. So I will talk about that in a minute. And the second part is the optical rotation. So it provides you the methods as well as the acceptance criteria for this identification method. And in terms of the assay, so here is the method. On the left-hand side, we provide you HPLC method, and we specified the sample preparation, the separation instrument, as is by HPLC, and the conditions such as the columns, the flow rate, injection volume, and runtime, and the detector. And we also provide the requirements for the whole equipment system and for this ingredient as well. So the ingredient criteria is called acceptance criteria. So here is no less than 82% calculated on the anhydrous basis. Additionally, we established the impurities levels and the methods for the arsenic and lead. And so the methods here is by ICP, and we have those detailed information in our appendixes. And we also have the acceptance criteria for them. And we have additional tests on the related compounds, the residue on ignition, the pH, as well as the water test. And the second example is whey protein concentrate and whey protein isolate. Here, I'm just showing you the testing part. And if you are interested, and actually this is the right timing because these two standards are in revision right now. So the proposals can be seen in the free FCC forum, and I will give out the link in later slides. And here we use two state-of-the-art identification methods for the identification. And the first is amino acid profile. The principle is that the amino acid profile testing, it can be a very useful screening to help substantiate the identity of a protein-rich ingredients, such as the whey protein concentrate and whey protein isolate. So the addition or substitution with foreign proteins can alter the amino acid profile of the ingredient, and then it can result in a material failing to meet the typical range that we prescribe in our standard. So when used for adulteration detection, this method can detect up to 5% of adulteration for fish gelatin, 5% for rice protein, and 10% for soy protein in those whey protein ingredients. So the scope of this test is that it can be used not only for the whey proteins, but also for a varieties of plant-based proteins, as well as infant formulas and adult or pediatric nutrition and infant food cereals as well. So this method is based on an AOAC 2018.06 method. So here are the typical results, right? On the left-hand side is the minimum and maximum amino acid ratio that we prescribe. And on the right-hand side, those are different proteins and different ingredients. So the takeaway here is that if we have samples with amino acid profiles that if you can tell here in green, it means that it's out of the minimum and maximum range, and thus can be subjected to further examination. The main takeaway here is that the spiking experiments have demonstrated then an ability to detect as low as 5 to 10% of foreign protein source, such as the fish gelatin, rice, or soy. And we also need to understand that the boundary here is not as narrow as possible, and it should be actually wide enough to include as many ingredients as possible while maintaining the selectivity of the method. And adding specific materials can start to deviate from the expected values. So such as for the middle column, that if you see the IF, the infant formula, if you add other ingredient in there, it can deviate it from the whey protein profile. And the deviations, of course, does not necessarily mean that it's adulterated, or there's maybe other issues. But then we need to have a confirmation by other identification tests. And the second identification method that I would like to talk about is the LCMS method to identify digested peptides. So the principle here is that the protein digested by a specific protease generates peptides, which are often characteristic of the protein used in the digestion. So the peptides generated in this way can be detected and quantified by a LCMS, the liquid chromatography mass spec system, to provide species information on the tested protein ingredients. It is a very useful way to help substantiate the identity of a protein ingredient. If expected peptides are missing or unexpected peptides are present, an investigation into mislabeling or an intentional adulteration should be performed. So the scope for this method is that it can be applied to not only the whey proteins concentrate or isolate. It can also be used in casein, pea protein, soy protein, and rice protein as samples or suspected adulterants. So for each of the proteins, they have their signature protein. So those signature proteins has its own signature peptides. As shown here on the middle column, those are the signature peptides. And on the right-hand side, those are the conditions, the Q1 and Q3 and the collision energy. And we set acceptance criteria for whey protein isolate and whey protein concentrate as below, which are that all three transitions of the beta-lactoglobulin, which is the signature protein in whey protein, are present, and their peak area ratios are higher than that of the system solubility solution, which is a mix of different proteins. And all the transition listed for the alpha S1 casein, the visilin, that's for pea, and the glutalin for rice, and then the glycylin for soy, they should not be present or have peak ratios lower than that of the system solubility solution 2. And here is an example of the whey protein using the method previously described and shown in a mass spec. And finally, FCC also has analytical materials. These materials are fit-for-purpose materials designed specifically for the food industry, and they can be used for method development, method verification, method transfer, method life cycle management, method validation, or for other purposes as needed. And one product we just developed, and it's actually right out of our website, is that whey protein method development materials. So this contains 4 different individual packs. So 1 whey protein concentrate and 3 whey protein isolate, all from commercial vendors. And the identification methods are based on 4 different state-of-art methods. So those are included in these materials, as well as the data that is analyzed on typical data typical materials of those. So they will be supplemental to the FCC standards and will be helpful for you to develop methods and also for other purposes. And so here are the links to our FCC. So the first one is the FCC website, and the second one is the FCC forum. So if we have any upcoming standards, then we will firstly put it into FCC forum. It's free to access, and you are welcome to provide your input, comments, feedbacks to in the FCC forum. And if you are interested in FCC and FCC newsletters, you can join by the below link. And that's all for my presentation today. And thank you so much. Here is my email address and the FCC website. Feel free to shoot me an email. And if you have any other inputs, feel free to contact my colleagues who are in the meeting right now. So thank you so much. Have a great one. Bye-bye.
好，
非常感谢啊，感谢Thank you, Mr. Xie. Thank you for your presentation. We are over time. So do you have any questions? We have some experts here. I know we are already over time. If not, then that's all for today. I think this is a very informative forum, and we covered the standard regulation, elderly nutrition, infant formula, and the quality and safety, and the risk factor, and etc. Thank you again for your presentation, and thank you all the experts. You spend a lot of time and efforts here, and thank you all the audiences. Thank you for your attention, and we hope that we can work together to promote the development of food industry, and we also hope that we can have a better and better meeting of CIFSQ. Thank you again. See you tomorrow next year in Beijing.